Sure, you're fine.
Okay, tonight's homework easy. Okay, so we start trig B with the sum and difference identities. Then when we come back, we'll have the double and half angle identities. I just said Tuesday or Wednesday will be speed quiz on the identity sheet. So anything on the identity sheet is going to be fair game. So it's going to look like this. You're going to have 20 of these. Sine x plus y equal.
Sine x plus
Cosine x over 2 equal. Cosine, no, tangent x over 2 equal, because they have 3 different ones, right? Same thing with cosine 2x, but have 3, so I'm going to have 3.
I do 10 minutes? 5 minutes?
I think 2 minutes. You're just regurgitating, right?
Is it handling
Cosine negative x, the co-function identities, anything on that sheet is fair game. Pythagorean identities, secant squared x minus tangent squared x. The identity sheet.
Is there a special way to memorize it?
No, these are identities. Yeah, these you just have to memorize.
You have to think of them on a circle. That's what I
No.
gave us, like a circle and he was like logical. But it's really confusing.
I don't remember that.
Wait, so like the speed quiz, you're just gonna need to recite the days?
Yeah. Otherwise you can't do
Do
problems.
we have to know, we don't have to do like cosine pi or something like that.
No, those are trig values, which we already know now. Although on the test, you can see that. Okay, cool. Some of you are getting the pi over 3 family mixed up with the pi over 6 family. That's why. Okay, come on, let's. Okay, I'm not going to derive these, but did Mr. Tucker used to derive them last year? You did, yeah?
Yeah.
Plus, it's in the book. I'm not going to derive them, but when you have cosine quantity x plus y, can I distribute the cosine?
No.
Yeah, you can, but it can be terribly wrong, right? There's an identity for it. Cosine, cosine, minus sine, sine. Does that sound familiar? Yeah, and then if it's minus, then it becomes plus, right? So you use the top sign with the top sign, the bottom sign with the bottom sign, right? You guys learned it last year, right? What about sine x plus y?
Same thing with sine.
No, it's sine cosine plus cosine sine. And then if it's minus, it's minus. And then what about tangent? X plus y. Can I distribute the tangent like this? Yeah, you can for the numerator. And then in the denominator, you got 1 minus tangent x, tangent y. Come on, these should all look familiar, right? And then if this is minus, then this is minus, and that's plus. This is all, you don't have to copy it down, it's all on the identity sheet. I have your identity sheet?
Okay, try to do it one more time.
Okay, go get it after. Or how about download it on the website
yeah.
and just
Yeah,
print that
I see that.
page.
Yeah.
Okay, now what kind of problems can you expect to get tonight? It'll be like this, okay? Compute the value of sine.
1 plus 1, 5 12.
Okay, pi over 12. We'll do pi. You want to do pi? Why is that the first problem on the homework?
Yes.
Colby!
Say no.
Strike 1!
David.
Just for that, we're going to do sine. No, let's do cosine. Cosine 7 pi over 12.
No, try 11.
Is that what's on the homework?
7.
Okay, no, it's not 7.
So you better do.
No, is 7 pi over 12 an angle that we're supposed to know? Anyway, if you convert this to degrees, that's 105 degrees.
We don't know that.
Yeah, we don't know that. But we can figure it out because we can write this angle as a sum or difference of 2 angles that we do know, right?
Yeah.
60 and 45.
Okay, 60
3
plus
and
45,
4.
there's
3 and
there.
4.
That's what I
3
said.
and 4. 3 and 4.
So you're telling me 4 pi over 3 plus 3 pi, wait.
No,
4 pi over 12 plus 3 pi over 12.
Yeah.
So can't that be reduced to pi over 3 plus pi over 4? Then?
That's what I said.
Yeah, I heard you. Yeah. Just that you're not acknowledging you. So that's like 60 plus 45, right, is 105 degrees if you think in degrees. Some of you still do. Okay, now once you do that, distribute the cosine and get a fatal error.
No.
No, you use the identity. Cosine of gorilla plus banana is cosine gorilla, cosine banana, plus or minus? Minus sine gorilla, sine banana. Oh, I forgot to mention that if you're on the math team though, Math team, you see this, you just write down the answer already. So when you see cosine pi over 12, you just go, whoop, small negative, root 2 minus root 6 over 4. That's the answer. Why are we laughing? Math team people here, make sure you put this in your memory.
Wait, how do you?
Yeah, that's what I know.
They just are so good at it.
Yeah, that's because we're good at it.
That's what he said.
Don't you want us protecting you? We are the special forces. We're special forces. Okay, now you gotta know your trig values. What is cosine pi over 3? Quick. It's too slow.
3 over 2.
1/2. It's 1/2. Cosine pi over 4. 1 over root 2 or root 2 over 2.
Root 3 over 2.
Okay, minus root 3 over 2 times, no, root 2 over 2. Now, in this case, it's better to use root 2 over 2 rather than 1 over root 2. You're going to find that true. Okay, so now if you make a least common denominator of 4, you get root 2 minus root 6 over 4. See?
It worked.
Why am I going to teach the special forces long things? You want me to give you the math team secret then?
Okay.
Okay, I teach it every year. I don't know if it's worth it to even, for math team, yes, it's worth, you have to, okay? But for the civilians like you, I don't know if it's worth it. Anytime you are 15 degrees from either the x or the y axes, that's pi over 12. Pi over 12 is 15 degrees from either the x or the y axes. Then when you take the cosine or the sine of it, the answer is going to come out plus or minus root 6 plus or minus root 2 over 4. And you can see why, right? No, because look, that's the numbers you get. When you multiply a root 3 times a root 2, you get a root 6. Right? When you multiply a root 2 times a 1, you get root 2. So you just have to figure out, is it positive, negative, large, or small? See, so here, cosine 7 pi over 12. Where is that? That's right there. What is the x coordinate of that point? Well, you're going to the left, so it's going to be negative. And how much negative? Yeah, no, small, look. Small. You go a little bit to the left. So what's the smallest negative number you can make with this?
Negative root 6.
Root 2 minus root 6 over 4. When I mean small in magnitude. It's a small negative number. Why is that funny? Here, I'll show you another one. What about sine of, okay, give me one.
3 over 2.
17 pi over 12. Where is 17 pi over 12? That would be right there, right? It's 15 degrees from the y-axis there. So what is the y coordinate of that point? It's going to be negative, and it's large. So what's the largest negative number you can make using these combinations? Negative root 6 minus root 2 over 4. Or if you don't pick this up, then just do this, right? Sum indifference identities. How hard is that? It's not hard at all. And then you want me to teach you the secret for tangent?
Yeah.
Okay, because here, what if you have to compute the tangent of, okay, give me one, 11 pi over 12. Of course, math team people, we just look at that and go 11 pi over 12, tangent's going to be negative small, so the answer is root 3 minus 2. But for the civilians, what we have to do, tangent of 11 pi over 12, we have to break up 11 pi over 12 into two angles that we do know.
3 pi over 12 and 8 pi over 12.
Okay, so that's 2 pi over 3, which is 8 pi over 12, plus 3 pi over 12, which is pi over 4, right? This plus this equals that, right? And then you use the identity. Okay, so what's the identity for tangent gorilla plus banana? Tangent gorilla plus tangent banana all over 1 minus tangent gorilla, tangent banana. And then now you just have to know your values. What is tangent of 2 pi over 3? Boom.
Root 3.
Negative root 3. And what is tangent of pi over 4? 1. All over 1 minus negative root 3 times 1. So doesn't that come out to negative root 3 plus 1 all over 1 plus root 3? Now we have to simplify that. And how do we learn how to simplify this?
Conjugate.
Multiply by the conjugate.
Was that on the test?
No.
Yeah.
It was.
Yeah, it was.
Yeah.
So you multiply top and bottom by the conjugate of the denominator. I'm trying to concentrate here. So that's equal to, well, isn't this the same thing as just 1 minus root 3? So it's just like 1 minus root 3 squared. So it's 1 minus 2 root 3 plus 3 then, right? And then over here it's a difference of squares, so it's just 1 minus 3. So you get 4 minus 2 root 3 all over negative 2. So if you lift and separate, you get negative 2 plus root 3. Exactly what I said from the beginning. And the math team secret is anytime you are 15 degrees from either the x or the y axis, when you take the tangent or the cotangent, it's going to be either plus or minus 2 plus or minus root 3. See, so when I did this problem, this is what we do. 11 pi over 12 is right there, right? What is tangent over there? It's in the second quadrant. It's going to be negative. And since it's near the x-axis, it's small. So what's the smallest negative number you can make? Boom. Okay, let's do it. What about tangent of 19 pi over 12? Well, do you want to do this, or do you want to go, oh, 19 pi over 12 is over there. Tangent in the fourth quadrant is negative, and it's near the y-axis, so it's going to be big. So the biggest negative is negative 2 minus root 3. Ha! Sito.
Never mind.
Okay. Anyway, tonight's homework is all just using the sum and difference identities, okay? 2 more examples and we're done.
What was the LC for it?
Logan Colby.
Oh, okay.
Logan Davis. Okay, do you remember this problem from last year? Tangent x is equal to 3/4, but x is between pi and 3 pi over 2.
Oh no.
Secant y equals 13 fifths, and y is between 3 pi over 2 and 2 pi.
No.
Yes. Compute the value of sine x minus y. Every trig book has this. This is a typical problem. How do you compute the value of sine of x minus y?
X and Y.
So the first thing you do, well, these are not values you know, right? Like for tangent, that's not 1 or root 3 or 1 over root 3, so we apply the identity. What is sine of x minus y? Distribute the sign.
Sine X.
Sine x, cosine y, plus or minus. Cool, some of us know already. Others of us, we just don't know, right? So if I just know the values of each of these 4 things, I just gotta plug it in and I'm done, right?
Yeah.
Okay, so how do I do that? Well, if you know what tangent x is, and you know what quadrant it's in, you can figure out all the other trig values. But what did we do last year? Draw a reference triangle.
Oh yeah.
So this is how most teachers do it. If tangent x is 3/4, and what quadrant is this in if you're between pi and 3 pi over 2?
Third.
You're in the third quadrant. How do you draw the reference triangle?
Like that.
Like this,
Yeah.
right? Tangent is what?
Oh,
Opposite over adjacent, so 3/4, and they're both negative, right?
Yeah.
Because in the third quadrant, you gotta go left and down, right? The hypotenuse will always be positive.
Yeah.
So if you want to find sine x, then sine x would be negative 3 fifths. Because it's opposite over adjacent. You just gotta know sokoto, basically. Cosine x would be adjacent over hypotenuse, so negative 4 fifths. So the quadrant is important because that's going to tell you whether it's positive or negative. A lot of people ignore the quadrants. Okay, now that's how your teacher teaches you to draw it in the proper quadrant. I don't do it like that. If you want to do it like your teacher taught you last year, fine. But this is the way I do it. I just draw the triangle the same way every time. I just draw it like this. Tangent of angle x is equal to 3/4, so it's a 3, 4, 5 triangle, and you're in the third quadrant, so just do that. Third quadrant. So when I compute the sine of angle x, sine is opposite over hypotenuse, but in the third quadrant it's negative. Cosine is adjacent over hypotenuse, but in the third quadrant it's negative. So I just keep track of the quadrant by putting the quadrant number there.
Well, why don't
But it's up to you. You can do anything you want, but you have to somehow keep track of the quadrant.
Why don't you put the negative thing first?
doesn't matter
because I don't want to. I want to be different.
But you use one more stroke, putting 3 lines instead of 2.
Okay, secant of angle y. Now what is secant? Secant of angle y, what is secant? It's the
Cosine
reciprocal
over
of cosine. So cosine is adjacent over hypotenuse, so secant is hypotenuse over adjacent. And it's a 12, 5, 5, 12, 13 triangle. Oh, so Mr. Park, you're going to use a lot of Pythagorean triples in this chapter. Yes! So I hopefully you know that. Now what quadrant are we in if you're between 3 pi over 2
Fourth.
and 2 pi? You're in the 4th quadrant, so I do this. But probably most of you want to do this, yeah? You want to just stick with the way you learned, right? You didn't learn this? Who's your teacher? I know he teaches this. So 13, and wait, secant is, so 5, 12, so this one's going to be negative and that one's positive because you got to go right and down there. Okay, anyway, I'm not going to do this, I just look at this. What is the cosine of this angle right here? Adjacent over hypotenuse, but in the 4th quadrant it's positive. What is the sine of this angle here? Opposite over hypotenuse, but in the 4th quadrant it's negative, so negative 12/13. So if you miss the sign, that's good. That's minus 2 per. So now we get the final answer. So that's 15 over 65 minus 48 over 65. So your final answer is negative 33 over 65. 3 cancels into 6 2 times. So you get negative 3 over 25.
Shouldn't the
Wait.
15 over 65 be negative?
What?
Negative 3/5.
Yeah,
What?
the 15 and the 3 and the stuff.
Where?
Right there, there's a negative.
Negative 3/5.
Yeah? It's negative right here. Let's know what the problem is. So the answer is negative 63 over 65. The 6's cancel out, so you get negative 3/5. You guys really have to say that? This is a joke, people.
I can like watch it video.
Okay, do you guys remember this problem from last year? Drawing reference triangles. Okay, now, like I told you last time, it's not enough to just know the identities one way. You gotta be able to do it both ways. So, and you gotta be able to low me. But not so yet. I think we'll wait for Monday to low me. Okay, so what if I give you a problem like this? Silence! Shh. Cosine. Shh. Try to concentrate. 5 pi over 12. Cosine pi over 12 minus sine 5 pi over 12 sine pi over 12. Okay, there's 2 ways to do this problem. One is the long way. Oh, I'm gonna compute this. Mr. Park taught me the math team secret. Cosine 5 pi over 12 is right here. So that cosine is gonna be a small positive. So it's root 6 minus root 2 over 4. Hey! Right?
So hard.
This is the math team secret. Cosine of pi over 12. Pi over 12 is there. Cosine is going to be large positive. So root 6 plus root 2 over 4.
Wait,
That's racist.
what?
I just taught you the math team secret.
No,
You just add up.
Yes, I know. But this is, yeah, you don't want to do this. You don't want to do this. You got to go, hey, you somebody, yeah? This is the identity for something. This is the identity for cosine of gorilla plus or minus. Plus banana. And then if I add these 2 angles together, you get pi over 2. Hey, that's an angle I know now. Everyone's a hero. That's 0. But if you did it the long way, you would come up with 0 also. But the problems are designed for you to start recognizing identities. You understand? You don't want to do things the long way. You want to go, hey, you somebody. So tonight's homework is easy, but when we get to the double and half angle identities next week Monday, then things are going to start getting hairy. Okay, let me pass back the test. You finished a little early.
You're too. No, there's no way. Every time, no consistency.